In this video, we are going to do fundamental problems for statically determinate structures. For this problem, we have to look for its reaction components at A, B, and C. So first of all, let's draw the free body diagram. And we have to remember here that we need to solve this problem by segmenting this whole structure. So therefore, first of all, I'll be dealing with member AB. For member AB, we know that there's going to be reactions at point A in both X and Y directions because it's a pin connection. And then there's going to be a single force FPC. And we also have a moment midway point, and it's 60 kilonewtons per meter. Okay, so first of all, let's solve the geometry of this structure. We are missing the length of member BC, and we can use Pythagoras theorem to solve this. So we know our length BC will be square root of 4 square plus 3 square. In solving this, we get 5 as our length for this member BC. Now let's take a moment about the point A, and we're going to assume counterclockwise as positive. When we take moment about the point A, the first moment we encounter is 60, and it's going to be positive because it's going counterclockwise. And then we have force FPC that is at an angle, and now we have to find our force FPC for y-axis, and we know that it's going to be negative because it's going downwards, that's clockwise, and our force FPC is simply going to be force FPC and then 3 divided by 5, or we could take an angle. The distance between A and B is 4 equals to 0, and solving this we get positive 25 kilonewton. Okay, let's take a moment about the point B. And when we take moment at B, we know we first encounter 60 as our moment, and then negative AY times 4 as our force. And solving this, we get 20 kilonewton positive. My bad, 15 kilonewton. Now let's take sum of forces in the y direction. We're going to assume up as our positive. Oh, never mind, because we already have all the y forces, so we don't have to take some of the forces in y direction, but we do need to take some of the forces in x direction, and we're going to assume left to right as a positive. So we know our AX is unknown, and then we know our force BC x-axis vector is negative because it's going the other way, which is right to left. So it's 25 times 4 divided by 5 equals to 0, and solving this we get AX as positive 20 kilonewton. Okay, so now we have all the vector for our member AB, and now we can simply look at our pin connection at C. So we know that there isn't any other force acting on pin connection C other than whatever force that is being exerted from point B. So therefore, whatever our Px vector is it's going to be vector for our Cx, and similarly our By vector is going to be same as our Cy vector, and therefore that's our answer. For this problem, we're going to use the same idea as before. We're going to work on one member, in this case AB, We know there is a pin connection at A, therefore there is going to be two vectors, one in X and one in Y direction. And we have a uniform load of 10 kilonewtons per meter. And we also going to have another force vector, which we'll name force BC, which is unknown for now. Okay, so first of all, let's get our equivalent point load for this uniform load. So it's going to be 10 kilonewton per meter times whatever the length of the uniform load is. That in this case, it's 4 meters. Times this, we get 40 kilonewton. And we have to remember here, our point load will be midway point between the distance of our uniform load. So in this case, it will be 2 meters from point A, or you can say 2 meters from point B. Okay, now that we have that, let's take our moment at about point A. We're going to zoom counterclockwise as a positive. So first we encounter point load 40, so it's going to be negative because it's going counterclockwise, times 2. And then we're going to encounter force BC in Y direction only because X axis component is at the same height as our point A. So this is going to be negative force BC. We know that our force Y will be sine 45 times whatever the distance is between A and B, and it's 4 in this case, equals to 0. Solving for force BC, we get so it'll be 80 divided by 4 sine 45. Take away this, so we get 20 over sine 45. So 20 divided by sine 45, and we get 28.28 kilonewton as our force for the vector BC. Okay, now let's take another moment about the point B in order to find the value for our point AY. So first we encounter our point load 40, and that's 2 meters away. And then we have a counterclockwise direction for AY, therefore negative AY times 4 meters equals to 0. Solving for AY, we get 20 kilonewtons positive as our answer. Now finally, we need to solve for our value AX. So for AX, we can take sum of forces in X direction. So I'm going to assume left to right as a positive. So we have AX plus we have our cos 45 times force BC, which is 28.28 kilonewton equals to 0. Solving this, we get negative 20 kilonewton as our answer for AX. So therefore, now for our point load or our pin connection at C, we know that whatever load that is going to be exerted by the point B is going to be handled or absorbed by point C, our pin connection. Therefore, we know that whatever our BX is, it's going to be our CX, and whatever our BY is, it's going to be our CY. Like and subscribe for more.